Today I would like to explain you quickly how to calculate torque or moment of force. Torque is not a force but an effect of a force causing a rotation. Torque has two important components. The force itself, basically how strong you are applying force, and the moment arm. What is moment arm? Moment arm is defined as the shortest or perpendicular distance from the pivot point to the line of action or force. Pivot point basically is the axis of rotation. So from when you open the door, the axis of rotation will be the hinge of the door. The formula look like T, which is torque, equal to F, which is the force, R is the moment arm. Torque is a vector quantity, so it has directions. So when we define rotation, we consider clockwise and counterclockwise rotation. Counterclockwise rotation is considered positive, and clockwise is a negative rotation. Next slide, I'll show you an example question. So we'll see example here. So you can see a force 3 Newton applying onto a leverage system. The length of this leverage system from the pivot point, which is a green triangle, to where the force applied is 10 meters, and the force applied with an angle 60 degrees. First step, we will identify the moment arm. So like we defined previously, it's the shortest or perpendicular distance from a pivot point to the line of action or force. Okay. How do you do that? First, you elongate the force line on both sides. You see this dashed line, you can see elongate to the front and the back of the force line. Make it longer, basically, make the force line longer. Then you from the pivot point, which is axis rotation, the tip of this triangle, you draw a line that's perpendicular to the previous dashed line, so-called line of action or force. So because it's perpendicular, so it's 90 degrees. This line from the pivot point to the line of action, the red one is the R, or so-called moment arm. Once you identify the moment arm, next you continue to calculate this length of this moment arm. We have to use the trigonometric function that we learned previously. First, identify the angle inside the triangle with the moment arm. So you see this red line, that is a moment arm, is within a triangle. You need to identify an angle besides the 90 degree that you already know. So you can see there's a 60 degree here, and right across that angle, it has to be the same degrees of angle. So this will be 60 degrees as well. Once you see this is 60 degree, that's your theta from trigonometric function. So your momentum will be opposite side of the theta. So when we need to calculate opposite side, we will need to use sine theta function. So we use sine theta, which is 60 degree, equal to R, which is your opposite side, over your hypotenuse. Hypotenuse is the 10 meter that was given previously. From there, both sides times 10, you'll figure out that R, which is our moment arm, is equal to 10 times sine 60 degree. And the unit should be meters, since the length, for the length unit is meters. Finally, we're going to calculate the torque once you identify the moment arm. Torque is force times R. So use the given force, which is 3 Newton, okay, times the R, which is 10 times sine 60 degrees. Together, that is your torque. And the unit will be Newton from the force and meter from the length of the moment arm. So Newton meter is a unit for torque. One last thing you cannot forget is the direction of torque. The way it rotates is gonna causing a clockwise rotation. And as we previously defined, clockwise rotation for torque is considered negative direction. And that's how you calculate torque for a simple question like this.